Welcome back, everyone. We're starting a new series and we'll be talking about algorithms. One reason for this interest of mine in algorithms is that a lot of tech companies might actually incorporate it in their interview questions because algorithms really tell something about the candidates or a programmer's way of thinking, how they approach a complex question and break it into parts, and how they deal with it. In short, algorithms may be the way companies might test your problem solving skills. To start this series, let's talk about one of the easiest sorting algorithms, which is the bubble sort algorithm. To see how the sorting algorithm works, take this example of 5 numbers that are unsorted. It first looks at the first 2 numbers and compares whether the number on the left is greater than the number on the right. If it is, then it swaps its places. Because the numbers here are in the right order, it moves on to the next pair. The same with this one, it's already sorted, so it will move on to the next pair. But in this pair, the number on the left is larger, so it will swap its places. In the final comparison, 64 is larger than 15 and some swapping is needed. This completes the first pass, and we now know that 64 is in its right place. For the second pass, it does the same with the pairs and finds 2 numbers where it needs to swap the left number with the right numbers. But this pass will exclude the last number 64 because we now know that it is already in its correct place. So by pass number 2, we know that there are 2 correct numbers, 64 and 32. You're probably seeing some patterns here already. By the third pass, it will still look for numbers where it needs to rearrange it so that the left number is smaller. But by the third pass, we will have 3 numbers that are already sorted. And by the fourth pass, we're sure that all of the numbers are in their right place. This means that we are expected to complete the bubble sort by n minus 1 because there are 5 elements. N minus 1 is 4. The fourth pass completes the entire bubble sort algorithm. Now that we know how the bubble sort algorithm works, it's easier to code it. So let's define a bubble sort algorithm, okay, which takes an array of numbers, okay, and the first thing we need to do is get the length of that array. We need the length because the number of passes will depend on this one. So now this will be the passes for I in range n. Recall that the algorithm is expected to be completed after n minus 1. We've seen that in action. And we're comparing the 2 elements. So to do that, 2 elements at once, we need to get their index. So for j in range, for the first pass, we are going to exclude the last number already. And then after the second pass, we're going to exclude 2 numbers already. After the third pass, we're going to exclude 3 numbers already because they're already in the right place. And for each of this, we are comparing whether the number on the left, for example, is greater than the number on the right, which is in the position of j plus 1. If it is, so this is a condition. If it is, we simply just need to swap them. And to swap them, we just get this one, okay? This is a simultaneous assignment, and we simply just exchange their positions. Now, to see this more clearly, we can have your print after pass of, let's document that, I plus 1, and then we can see what the array is, and that should be it. So here we can try the numbers that we've seen earlier. So the numbers that we've seen earlier are, okay, so the numbers that were given as a 5. Let's make it into an array, okay, or maybe just a list. I think a list can work. So we have 18, 15, and we'll input it here. So after the fourth pass, you could verify with our primer video that this is the same case. The bubble sort algorithm comes with some key advantages. First off, it's very simple to understand and it's also very memory efficient. Memory efficiency in this case means that every time we exchange the position of the elements to sort them, we weren't creating copies. This means that there's no unnecessary burden to our memory. But it also comes with some key disadvantages. As you saw, it's inefficient for very large datasets. The multiple passes likewise is inefficient, especially if the array is already sorted when you enter it. And in turn, because it goes through every element minus 1, it has a very slow performance.